In this video, I will be showing you the general requirements related to safety for electrical medical devices. At the end of the video, there will be a link to a free template that you can use as a guide when you identify essential performance for your device. Hi, I'm Claus Rømer. I am an expert on the 60601 standard at Medical Device HQ, and I'm a member of the Technical Committee 62 that authors these standards. This video comes from my online course, Introduction to Safety for Electrical Medical Devices and IEC 60601, that is available on medicaldevicehq.com/60601. If you don't want to miss out on more premium content from our online courses, subscribe to this channel by clicking on the subscribe button and click the notification button. Not only will you be kept up to date with what videos we publish, but you are also helping us reach out to more people that work with medical devices. I hope you will enjoy this video. Let's get started. In this video, I will introduce you to the general requirements related to safety, as defined by IEC 60601-1. Most of these requirements will be relevant to you, no matter what kind of device you're working on. You must design the device to meet these requirements in both normal use and in foreseeable misuse. ISO 14971 defines reasonably foreseeable misuse as use of a product or system in a way not intended by the manufacturer, but which can result from readily predictable human behavior. The device shall meet the requirements of the standard in both normal use and in reasonably foreseeable misuse. Reasonably foreseeable misuse means that it is predictable use which is not included in your definition of intended use of the product. So there is a part of abnormal use which is out of scope because it is not foreseeable based on readily predictable human behavior. I have already covered some of the requirements related to risk management. Remember to evaluate the adequacy and suitability of particular hazards, technical requirements, and acceptance criteria through your risk management process. Also, the risk management process shall be used to identify essential performance, which we defined earlier. This analysis shall include performance limits for relevant functions. The expected service life is defined as the time period during which you expect the device to remain safe for use. This time period shall be stated in the risk management file, though there's no specific requirements to justify it further. The standard allows you to apply risk control measures and test methods which are different to those defined by the standard. This can be relevant in special cases not considered by the standard. You must demonstrate that the residual risk is acceptable and comparable to that defined by the standard. You shall also assess parts that can come into contact with the patient, but do not meet the definition of an applied part. Your risk assessment determines if the part shall meet the requirements for a type B, BF, or CF applied part, except from labeling. At this point in the course, it is time to discuss single fault conditions from a different perspective. Generally, devices shall be defined and manufactured to remain single fault safe, at least if you cannot demonstrate that the risk remains acceptable in case of a fault. You have two options for each design feature that shall be single fault safe. The first option is to define the feature in a way where you can demonstrate that the probability of failure is insignificant. Examples include reinforced insulation, a mechanical tensile safety factor of 8 times, and choosing components with high integrity characteristics. Your second option is to implement two independent risk control mechanisms. To qualify, you must justify either that the initial fault is detected before the second mechanism fails, or that the probability of second fault is insignificant. Both options shall be reliable over the expected service life of the device. Your risk analysis determines which single faults shall be evaluated by test or simulation. As all medical electrical equipment need an electrical supply of power, there are a few general requirements to the power supply. The power supply can be supply mains, a special separate power source, or internal, such as a battery. The standard specifies a maximum rated mains voltage corresponding to the typically available AC mains. It also provides general assumptions on the supply mains voltage. These are overvoltage category 2, used to determine test levels for mains transient voltages. So unless you specify otherwise, the requirements for category 2 apply. You can assume the mains voltage is between 90% and 110% of nominal and practically sinusoidal. The mains frequency is below 1 kHz and the deviation is 1 Hz. Under these conditions, the steady-state input power to the device shall not exceed markings by more than 10%. This was a summary of the general requirements as defined by Clause 4 of the General Standard. Many of these requirements are the key to identify specific requirements according to the later clauses in the standard. There is a template on medicaldevicehq.com that you can download for free that highlights what areas you should cover when you identify essential performance of your device according to the requirements of IEC 60601-1. Before you get to the link, I'd be really grateful if you subscribe to our channel by clicking the subscribe button. If you want to learn more about safety for medical devices, I welcome you to register for my online course, Introduction to Safety for Electrical Medical Devices and IEC 60601 through medicaldevicehq.com, where I will take you through my approach to proactive safety by design and teach you how to work efficiently and safely according to the requirements of the 60601 standards. Use the link to get the template from medicaldevicehq.com. Before I go, I'd be really interested to hear your thoughts on safety for medical devices. Please answer the following questions in the comments fields below. 1. What do you think is most challenging? And 2. How do you usually manage these challenges? Thanks for watching.